Hi, everybody. It's good to see you. Welcome to the Space Generation Advisory Council U.S. Earth Observation and Applications webinar. So I am one of the national points of contact for the Space Generation Advisory Council U.S. Group. My name is Gabriella, and Lindsay is here with us too. Lindsay, would you like to say hi?
Yeah, hi everybody. I'm the other U.S. national point of contact, and I'm here to help with logistics for this one and let Gabriella moderate. But yeah, I'm great. I'm happy that you're all here, and I'm happy that we'll be able to share this recording with all of our members.
Perfect. Okay, awesome. And so I see we've got our three panelists here. I'm going to introduce each one of them and then give them a chance to say hi. Okay, so our first panelist is Dr. Jaitza Luna Cruz. Dr. Luna Cruz is an atmospheric physicist and program executive in NASA's Earth Science Division Data Systems at NASA headquarters in Washington, D.C., where she also serves as program manager for the Early Career Research Program. In her dual role, she leads the digital strategy and user engagement activities and helps oversee opportunities that support the next generation of Earth science researchers. She has more than 12 years of experience in research, development, operations, and program management, including work with atmospheric transport and natural hazard modeling. Dr. Luna Cruz holds a PhD in atmospheric physics with research focused on aerosol cloud interactions in tropical cyclones, and earned her bachelor's in science and master's in science in physics from the University of Puerto Rico at Mayagüez. A passionate advocate for STEM education and mentorship, she has received recognition for her leadership and outreach efforts aimed at increasing opportunities and participation in STEM for all. Jayita, would you like to say hi?
Hi, everyone. Happy to be here with you all.
Perfect. All right. So our second panelist is Dr. Jack Kay. So Dr. Jack Kay served as the Associate Director for Research in NASA's Earth Science Division within the Science Mission Directorate, overseeing the agency's research and data analysis programs that advance understanding of Earth as an integrated system. Over a distinguished 41-year career at NASA, he held key leadership roles, including space scientist at Goddard Space Flight Center and manager of the Atmospheric Chemistry Modeling and Analysis Program at NASA headquarters. Trained in chemistry with a bachelor's with a BA from Adelphi University and a PhD from the California Institute of Technology, he also completed postdoc research at the U.S. Naval Research Laboratory, bringing a strong scientific foundation to his work. Dr. Kay represented NASA in numerous interagency and international collaborations, contributing to global change research initiatives and advancing multidisciplinary Earth science. He received many honors for his contributions, including NASA's Distinguished Service Medal and the 2024 William T. Pecora Award for Excellence in Earth Observation and Research Leadership. Jack, would you like to say hi?
Yeah, hello to everyone watching. Thanks for joining us.
Perfect. Okay. And so our last panelist is Cassie Lee. So Cassie Lee is an aerospace leader and co-founder of the Brooke Owens Fellowship, an award-winning internship and mentorship program designed to elevate undergraduate women in aerospace. She began her career as a propulsion engineer at NASA before holding a range of technical and strategic roles across the aerospace sector, including at Sierra Nevada Corporation, SpaceX, and in climate and remote sensing programs. Lee has led the development of impactful space solutions at organizations such as Earthrise Alliance and Vulcan Incorporated, focusing on climate change, ocean health, and conservation through data-driven technologies. Beyond her career, she is a passionate advocate for gender equity in space and serves as a mentor within the United Nations Space for Women Network. In her current work, she blends innovation, leadership, and community engagement to support the next generation of aerospace professionals and expand opportunities across the space ecosystem.
Awesome. Thank you so much for including me in this conversation. I'm really excited to dive in.
Yes, absolutely. Yeah, I'm excited to hear what we talk about. Okay, so our first question that we're going to talk about today is, so looking ahead, how can space-based Earth observations be translated into practical, user-friendly tools that empower local, regional, and global communities to make informed decisions? Okay, I'll let you guys jump in.
I can start on this one because I really like to think of a lesson that I learned very early on in my career in the Earth observation field, and that was, we can design and launch and operate a whole variety of different satellite sensors, phenomenologies, constellations, and we can pump as much data down as we want. But if we're not thinking about the use case and the user first in designing systems that meet the folks with the greatest needs where they are, then all that information just gets lost in translation. And so, as we think about what tools look like, it's been very interesting to see the rise of all of the companies that are in the application specific space, and even going beyond that. People don't even need to know where their information came from, as long as they know that it is of high integrity, and there is a strong chain of custody. That information it turns into actionable insights, so that people can make the decisions that they need, that they know best in their area. So thinking about use case first, and then using the vast array of satellites that we have on orbit to collect that data. And that can happen. We should be thinking at hyper local levels, and then looking across those to see where are the themes, so that we can bring that into regional and to global communities.
Yeah, I love what you said, Cassie. Yeah. One of the things that we talked about at the last space generation meeting was basically what you're describing. So that challenge between getting satellite observations, but then actually getting it in terms of like user-friendly resources. And so right now I know that there's so many that like, sectors in government and private companies have, but yeah, it seems like there's so much information. And so the challenge, at least like when I think, is like how to make that accessible to companies, and basically putting it in like a packaged way that is usable and useful for them. So,
yeah.
Mm-hmm.
I can give the NASA Earth Science Division perspective. We have been thinking about this in the last few decades, and particularly in 2024, we launched the new vision of the Earth Science Division, which is the Earth Science to Action strategy. And that strategy, I love it because it includes all the life cycle of Earth science, right? So from data, foundational knowledge, technology, to research, application, and then that engagement with the different stakeholders, private sector, local people, communities, globally, locally, and creating this virtual cycle and interaction with the technology that is driving then the research, the data. And I think to make it more usable for people, we need to focus in 4 things. I think first is making that co-production. So involving the communities that are affected in the co-productions of the solutions. Also enabling technology. For example, at NASA, data systems is always looking ways to enable people to use our data and the different tools. And for that, we need to adapt and evolve with the new technologies that we have. For example, artificial intelligence, machine learning tools, etc. Also training. Training is very important. It's not only creating tools and only putting the data out there, it's also creating training so that we build capacity at the different levels at the communities, and also strategic partnership. So in order to create that connection with local, regional, and global communities, we need to have strategic partnerships that allows NASA Earth data to be out there and to be more usable and available for the human, for every human in this planet.
Yeah, I love what you said. I think one of the things that I think is so cool is the NASA TOPS, the transition to open science. Yeah. When we were talking a little bit about that, it seemed like what you're talking about with like that training. I think that would be one thing that would just help it to be much more accessible and that type of thing. But yeah. Mm-hmm.
Yeah, I can weigh in. A lot of what I was going to say, I think, has been said, but in my mind, a real important thing, and as I said, I don't think this is new, is to try to, as much as possible, for those who are producing the data, to think about how the people that you're looking to have using it are doing their jobs. What tools do they use? And say software systems, and how do you facilitate the things that the producers are putting out to make it as simple as possible to get into the tools that people use? Because if you want new people to use your data, and especially from a NASA point of view, where historically a lot of what NASA did was produce data that never before existed in the history of the universe. And if you want people to use something new, you can't expect them to learn how you put the data out. You have to get it into the tools and the software systems that they're used to using, which makes it much easier for the uptake. And I think that's a continuing challenge because uh, the tools are advancing so rapidly, the software is changing so much. So the lifetime of software systems is maybe years, and you get things like AI coming on. So you really have to think about what will make it easiest for the user. Sometimes in the old days, the data was put out really for the convenience of the producer. And it's like every time you try to read a new data set, it's like you were going back to kindergarten. You really had to learn from scratch. It was hard, the only reason the system probably works so well was a lot of graduate students who did the legwork to try to figure out how to access things, and that doesn't work if you're trying to get commercial and municipal people doing that.
Yeah. Yeah, I completely agree. I think one of definitely the biggest hurdles is like I love how you worded it where you said we can't rely on like them to learn how we put the data together. And so just keeping that in mind when we do that, yeah, is so important. Yeah. Does anybody have any other things to add for this question? If not, we can move on. But okay. All right, so the second question is, what emerging or evolving partnerships between government, industry, academia, and communities do you see as the biggest opportunities for strengthening climate resilience in the next decade?
Well, I'll jump in quickly, but and it's a little vague because a lot's being done already. It's certainly don't want to create the sense that nobody's thought about this before. There's a lot of really good work that's going on, but in my mind, one of the things is that uh, to help need to help people make connections, in some cases between very different kinds of things, potentially like looking at local data in the context of the local representation in global models, and potentially say comparing some things that relate to human activities in a specific way and some things that relate to Earth system responses to human activities in a more global sense. So, say if you're trying to deal with coastal resilience, you need to be able to really think hard about uh, sea level rise, changes in severity of severe storms, but also local subsidence, which could be coming from water withdrawal or petroleum withdrawal, and also think about land use changes, potentially mangrove losses and things. So you're combining the global and the local, and anything that the community collectively can do to make it easy for people to connect those things that otherwise might seem separate will be really important because I think for resilience, making those connections between the local and the global, or the local and the local manifestations of the global, is going to be really critical.
Yeah, and just to pull on that thread one step further is to then share the resilience efforts that work or don't work, or where what element, let's say, of the entire response or resilience uh, concept, maybe where things failed. So I'm thinking about the utility of everything from governance practices and the financial pieces, as well as exploring the emerging GeoAI field and being able to look and compare through time to find places that are similar, and where interventions worked or didn't work, or use that to help us get into the prediction, which is, of course, the holy grail of climate resilience, and helping us figure out what levers we can pull now in order to have a more promising future. But really just, the integration between government, industry, and communities, as well as, of course, support and really exciting forward thinking that we see coming out of academia is the translation of that information across borders. Because as we know, our climate issues don't stop because a border has been drawn on a map. And so how do we think and learn at a global scale what interventions work, or where we see things that start to fall apart, or where are there excellent best practices that could be used to help save areas that might become at risk in the future.
I'm just going to add that at NASA Earth Science Division, we are trying to create more awareness of the different resources that we have, the different work that we have. We have the Earth Information Center. We have, because different ways in which we do outreach, because when you create awareness, this partnerships happens organically. So we have seen an increase in for example, NASA have ROSA solicitations, which are the mechanism in which we fund people to do research. We see more interactions with different stakeholders and community and the private sector and the industry. This year, we released even a new program that is just dedicated to commercial sector. So we have been seeing an increase of awareness in what you can do in terms of using NASA Earth data in the different sector, across the government with other agencies, industry, academia, and also communities in general. So I think this happened organically, but it's up to us to create more awareness of what we can offer in terms of data, resources, and knowledge in earth science.
Mm-hmm. Yeah, and I want to put an exclamation point on what Dr. Luna Cruz said. NASA has so many resources. And to go back to our first question, right? Like, how do we connect those resources to the people that need them the most? And I think awareness is absolutely step number one. To Dr. K's point, having the accessibility through the systems that are already known by the user community. I think it's a huge opportunity for our community as a whole to share the power of what Earth observation from space offers to folks. I mean, when I first, went from the propulsion and human spaceflight side of things to working in the remote sensing capacity, my mind was blown in terms of the kinds of problems that we could solve, the things that we could see, the problems that we could see as they were emerging, so that interventions could be placed. It's absolutely incredible. And so thinking about how we pull that forward and use hopefully this community as sort of a microphone or megaphone for all of the capabilities and opportunities that exist now, and all that will continue to emerge through the commercial environment and global government.
Yeah. Oh goodness. Yeah, I totally agree. I feel like it's really, really incredible just seeing how many resources there are. And so I feel like with more and more missions and more like use of like AI and just partnerships and things like that, there's no shortage of resources. But I feel like the challenge is specifically how to highlight those and make those relatable in a way that's useful to communities and things like that. Yeah. Mm-hmm. Okay. Does anybody have anything else to add for this question, or should it go to the next slide? Okay, sounds good. Right. So the third question is, so for students and early career professionals who want to make earth science more accessible and impactful, where do you see the greatest opportunities to contribute?
I can start that one because by my nature is early career. Right. So I have to say that we know that NASA have a lot of data, a lot of resources, a lot of information, but you're listening right now, you don't need to wait for the right opportunity to engage with NASA, because let me tell you, all this NASA data that we're talking about, all the resources are free, open, and available for you. And I have to say that in the recent years, we have seen the amazing work that the early career research community is providing to earth science. I always say that early career researchers are paving the way for the next generation of earth science, and that's very important. So what I want to convey here is that your voice is needed, your innovation, your creativity, your ideas is needed now. and you have the resources to do it and engage and explore with NASA Earth Science Division. So there's gaps in many areas. We are collecting a lot of data. So we need to process all data. So there's gap and skills needed in artificial intelligence, machine learning, cloud engineering to process all that data. We need also to translate the science that we do in things that people can understand and use. So that's another area. We also have a lot of interdisciplinary cross-training and cross-discipline needed to understand the Earth system science. And also, we need to develop more tools and resources that are open and available for all. So there's a lot of potential here. You don't need to wait for an internship or finish a PhD or, be in the NASA workforce to actually contribute and start being part of the Earth science system.
100%. I love that answer. And it touched on all of the points. I just want to frame a few. What I have the great privilege of getting to do and working through not only Brooke Owens Fellowship, but our fellowship community, is to see the problems that individuals in very early career want to solve. And there are so many problems that need attention. And a lot of times, like we were saying, it takes people from those communities with that perspective, with that experience to bring that forward. And then those that are interested in working on the data side can access the free and open data and make that accessible to the communities, their own community that needs it most, or the ones that want to storytell around it or translate it or turn it into a business. Like they're up there. The satellites are up there. The data is coming down. And if you can connect that available and emerging data set to a problem that you're really passionate about and bring your skills, others will join. And it is a really, really exciting time to have just absolutely unfettered access to incredible insights where you can go off and solve problems that are meaningful to you and your community.
Yeah, I was going to make a similar point. I think that from my perspective, if you start thinking about the greatest opportunities to contribute where you can have the biggest impact, it's doing something that you really are passionate about, something that it's not work, but it's joy, it's passion. Sometimes I think people say like, well, what subfield is the best one for me to go into? What's going to be the hottest one? Where will there be the most opportunity? And my sense is if your heart's not in it, just trying to pick what someone is telling you is the best opportunity is not necessarily likely to be successful. If you're doing something that you really like and care about, that positions you well to do that. So that's the first thing I would say is do something that you care about. And then the second thing is, especially in terms of accessible and impact, don't, as best you can. And for a lot of us who are trained in science, especially, say physical science, this is not necessarily something that comes natural to us. But think about the people who, and the entities that would be looking to use the information that you're trying to share. So that means you have to talk differently than the way you talk to your peers and at scientific meetings. You got to de-jargonize. You got to figure out how to balance data with stories, because in some cases, just giving people more data is not going to be terribly helpful. You have to reach them. And I would say you also have to think about, especially in terms of accessibility and impact, how do you reach all the people that need to know about things? It's very easy to sort of say, well, like there's a group that's well positioned to work with. I'll talk to them. But that's not necessarily everybody. For instance, right now, sometimes people say, well, just everything's online, put it online. And especially there's generational differences. There's still senior citizens with flip phones. And if you say, well, I'll make a smartphone available, that's not going to help them. So how do you help make sure that nobody gets left behind? Or and for the entities that are working to make that combination between the data and recommendations, like evacuation in the face of a storm. What do you do for people who don't have cars? If you don't really think about the inherent, differentiation among the people, and the entities that are looking to respond to environmental information, especially related to resilience, and response, you know, people are going to be left behind in some cases, literally. So I think for accessibility and impact, think about uh, all who can be affected.
Yeah. I love what you just said. I love yeah, I want to highlight what you said about just knowing like around you what problems exist in your communities. Because I feel like a lot of the times, like, since you're in your community, you're like most connected to the problem. And so if you're able to yeah, think about like a solution, it can be really, really helpful in that sense. I want to ask you guys, do you guys have any like recommendations or ideas for either like educators or citizen science to get involved with NASA? Or well, not just NASA, but private or anything like that. I know that there's so many opportunities, but yeah. Are there any that come to mind for you guys? If not, it's okay. But
Well, we have the Office of STEM Engagement that they provide different programs that are tailored for that communities. And also there's EPS programs like NASA EPSCoR that are at local level, that they are engaging more with the citizens in the local problems. We also have Space Grant is another way to interact with NASA projects that are more local and tailored for different communities. We also have the Citizen Science program at NASA that provides different opportunities. So there's many ways to engage. As Jack mentioned, at NASA, we are always trying to find all the gaps between the different communities and try to create programs that are tailored for the different communities, because we understand that you need to meet people where they are. And yes, there's plenty of opportunities for citizen science and engaging with communities.
Yeah, and one particular program that's been around for a while, but I think it's likely to be going through some evolution, the GLOW program, Global Learning and Observations to Benefit the Environment. It's been around 30 years. It started as a student-oriented program to get sort of teachers trained to make observations in schools. A citizen science component was added to that. As Shades mentioned, through the Office of STEM Engagement. So the globe has been well over 100 countries, and there's over 250 million environmental observations that have been made. So there's the Globe Observer app, and as I said, some of the particulars may change, but for people who want to sort of see, what can I do myself? That's a good place to start and try to follow it through with whatever future evolution may be.
very, very cool. Okay. So with that, we can move on to our fourth question. So our fourth question is, which current or next generation remote sensing technologies excite you most for their potential to support regions facing environmental, economic, or societal challenges? I love this question.
I do too. I do too, and I have an answer. Hyperspectral imaging is something I'm so excited about. There is, of course, in a standalone capacity, it is extraordinarily valuable to solve so many different kinds of problems. But some of the stuff coming out of academia in terms of how you mix and match, hyperspectral and LiDAR, you can really start to learn so much about our planet and get us into a position where you can, once you start to see where change is happening using this data, then you can intervene. And certainly, we are all so excited about resilience opportunities and preventing some of these really painful and to the planet, painful to the humans that live there, the impacts of what's happening around the world. And so if we can get ahead of that, And the smarter that we can get and the earlier that we can see those things, I think that's really exciting. And then I'll just also mention too, space is incredible. It doesn't stand alone. And so over the years of building and deploying programs, I've gotten a very good appreciation for airborne observation and in situ observations, and how we tie all of those things together and use each element or each altitude, even underwater, right? Underwater remote sensing as well, and tying those things together to teach us more than we could have ever imagined that we would get to know about places, areas of the world, and different ecosystems that might really unlock a really strong future for all of us.
For me, if you ask me, I was born and raised with airborne science, so I'm pretty excited about the next generation of airborne field campaigns that are coming, and establishing that connection between satellite and ground validation, etc. So we are very excited for the new airplane that NASA is gonna have eventually next year, the B777, which is gonna open a lot of opportunities in terms of discovery and that connection between airborne science validation and satellite observations, and also bringing also students opportunities within the resources that we have in airborne science is something that I'm very excited about. And I have to thank Jack for that, because he was part of that. So yeah, that's something that excites me about bringing the next generation also into these new technologies that we are developing.
Yeah, and a couple of things that I can say, and in terms of sort of choosing among between technologies, it's so the analogy that we use is like, which one of your children do you love more? And you never really want to answer that question. But one of the things that certainly we've finally gotten to do at NASA is to really increase temporal sampling. So many of the satellites that we've had at NASA would be in sun-synchronous polar orbiting satellites, and the Earth is turning the satellites orbiting, and with one satellite, you can maybe look at parts of the Earth twice a day, or once if you need daylight, or none if you're trying to see through clouds. So when you get to satellites that can give you much more frequent sampling, whether it's by virtue of being higher, like geostationary orbits, which we now have the sort of the global geostationary air quality constellation with Korea with GEMS, us with Tempo, and Europe with Sentinel-4, I should say, in that order, or with constellations of small satellites which is what a lot of the commercial things are doing, that let you look at things more often, and for things that have diurnal cycles, or things that you really want to be able to catch more often because they're happening rapidly, especially, say, responding to disasters, to being able to characterize their extent. That more frequent observation will be really valuable, and you see that in the applications world. And of course, as new techniques come along, like the hyperspectral that Cassie mentioned, and when you start thinking about, now you can get temporal sampling and spatial resolution and spectral resolution, and maybe get all of them, that's going to open up a lot of opportunities. The other thing that's coming along too, because of this idea of temporal sampling, there may be ways with other kind of platforms, including on the airborne side. You hear them called HALE, or HAPS, high altitude, long endurance, or high altitude pseudo satellites. A lot of the platforms that have been developed for that don't have a lot of payload capability. But for some things, if you have, say, one really good hyperspectral sensor, maybe that's okay. Or if you can combine a hyperspectral sensor with a LiDAR or a radar, so then you can get sort of spectral and vertical information that can be very useful. So I think that's something that, as the platform technology evolves, making sure that the sensor technology evolves as well, because in the end, for airborne, it's a very you really need a good, strong relationship between the platform and the sensors and the systems and the people in order to fully benefit from what a platform may give you. If you have a great platform, but the sensors are too heavy, then they're not going to fly. So you need both.
Yeah, and just to pull on that thread a little bit further too, is to think about, what we can do in space and how we make more out of the sensors that are up or are the sensors that are slated to go up now. You can think of things like virtual constellations where you have, different phenomenology satellites that are all flying over the same area, collecting lots of different information at a high temporal revisit that gives you a lot of really deep and rich information about a specific area of interest. You can also get into, a tip and queue scenario, and that's something that certainly is a lot of folks are investing in now. Where if you have a really broad range or low resolution sensor that finds something that's very interesting, then it can tell the next sensor that goes by to collect more information on that, whether it's a different spectral signature or whether it's just a higher resolution. To really get into, and as long as we get into that. The shorter and shorter time cycles on that information or the sensors connecting with each other, we can really do a lot of very interesting things and learn a lot about the planet as it's changing.
Just adding to that one point is that for a lot of things in remote sensing now, that's true for short term. It's especially true if you're looking at long term. Um, and users are not necessarily going to be looking at, what can one system tell them about what they're looking for. They want to be able to look across all the systems that are out there, producing similar but maybe not identical data. So how do you, if you're looking at a long-term trend, how do you create that multi-instrument, multi-platform, multi-program trend that you need to do? Or if you're trying to look at, say, short-term evolution and maybe integrate across data sets from multiple providers, how do you work across them? Will there be enough information available to let you confidently do that? And as a community, how do we support each other? For things like calibration and validation that are expensive and opportunities are limited. If you think of that as not just how can our program do CalVal for our own missions, but how can we treat that as sort of a global good and think about CalVal, which is, say, if we're doing an airborne campaign and we can underfly somebody else's satellite to get complementary measurements, let's do it. At NASA, one of the things that we did worked with the European Space Agency to do a lot of that, to get precursor data and then to get post-launch data. In some cases, say if we had airborne instruments that they didn't have, where they had airborne instruments that we didn't, or like a couple of years before the NISAR mission was launched with Israel, there was a airborne campaign with the Indian S-band and L-band airborne radar to get precursor data sets that the community could use. But that was a joint activity that neither of us could have done ourselves, and it just makes the whole enterprise more effective if we can work collectively and mutually support each other.
Yeah, and I'm gonna even go a step further. And when we think about collecting this information and doing bringing together different providers to gather information, what we're all really doing this for, to the point, Gabriella, that you made before. I was like, there's all this data. The point is for it to have a positive impact and affect a change or hold bad actors accountable. And so, in talking about next generation and inspiring people to participate, there is so much that can and should be done in the legal field in terms of bringing a lot of these emerging sensors into a place where we can actually utilize this capability and hold people accountable, or even get into an enforcement practice where this information is not just collected and we see what's happening or we intervene. It's, we actually can, as a community, be part of a solution set that really pushes forward for change. And so anyone that's participating today that has a curious mind in the legal field, we need you. We need everyone to bring their unique capabilities to bear to make sure that this data turns into positive action.
I love what you guys are saying. Yes. I'm just going to reshare my screen real quick. I'm so sorry. I think um, something with my internet is going on, but okay, I'm going to reshare for the last question. Let me know if you guys can see the slides again. Let's see here. Great. Are you guys able to see the screen again? Yes, perfect. Okay, awesome. Yeah, that was so cool. I love what you guys were saying about like how to combine like information from different sensors to fill in those gaps, but then also now with the new orbits and technology that we're having, we're able to like do that and have it validated by the actual satellite. And it's just so cool. Yeah, I remember yeah, you know, most of the issues before just being kind of how to fill in like missing data, whether it's spatial, temporal, or even if you just have clouds covering the area. But yeah, it's so cool using you know, things like machine learning and things like that to be able to fill in those gaps, which is really amazing. Um, yeah. Okay. So with that, we can move on to the last question. Again, let me know if something is wrong with my screen if you guys can't see, but perfect. Okay. So the last question is, what is one, oh, let's see. Yes, okay. What is one concrete, achievable way communities can start using existing Earth science data to improve preparedness and build a more resilient future?
I can start that once. I think Casey and Jack already mentioned this, but I'm going to touch again, is communities needs to identify what is their problem, because that's a good starting point for them. For example, if it's fires that are affecting them, so it's okay, so this is the hazard that is affecting me. Then you know that there's different local groups that can gather together with academia, local academia, or nonprofit organizations. If they understand the user needs, meaning what is their problems, I think that's the starting point. So what is one concrete achievable way communities can start is understanding what is affecting them, because that's going to inform a lot the people that provides the data and the resources to identify the different tools that are already in existence. I use fires, for example. So if the community knows about fires, the local emergency managers, the rangers, the forest people, the individuals, the communities, then they can discover that there's a tool, for example, FIRMS. FIRMS is the NASA's Fire Information for Resources Management System. And that tool provides near real-time data that they can use to identify the hazards that they have in the community. So, but everything starts in the community, because they need to understand what is the problem that is affecting them, and then reach out. And there's, as Jack mentioned before, there's a lot of data, but if they don't know how to use the data or access the data or translate the data, there's a gap. So it's like identifying the problems and then create these partnerships to help communities with training and resources to then fill that gap in that particular problem that they have.
Yeah, I mean, and just, you know, even step zero of that is just to realize that space is available, right? Like information from space is available to these communities. I think that there's a perceived, you know, giant gap of discomfort, or not even thinking about having access, free and open access to this incredible information. And so thinking about space is a critical element of your preparedness life cycle, of your emergency response life cycle, of your recovery life cycle, and your resilience life cycle. And so the more that we can do to, you know, amplify the accessibility now of space-based data and remote sensing, I think more people can be served immediately just by putting that, you know, on the table to say this is now available.
One thing that I would say, and I might alter the question a little bit, or liberally interpret the language because the language is specifically about using earth science data today. But if you're talking preparedness and a more resilient future, you have to actually think about how the future may be different from the past. Um, and that requires the use of models. And there's a challenge there because someone can always say, well, how do we know the model's right? And there's a good chance the model will not be perfect. Um, but if you are trying to prepare for the future and you don't look at what the models are telling us, and the models are all heavily informed by data, especially satellite data. So in many cases, you say model, but it's really this sort of observation model hybrid products that are based on the best science. But if you're thinking about the future, you got to look at the data and look at the models, understand some aspects of the limitations, and I would say, you know, look at the extreme events, because in many cases, what's going to get you, if something's going to get you, it's not a slight shift in the mean, but a slight shift in the mean could be accompanied by a fairly substantial change in extremes, both in magnitude, extent, frequency, duration, whatever, and really think about that, and also think not just about, say, one hazard if you're in the disaster thing, but what about uh, combine successive hazards or cascading hazards, and really think about that because if the Earth does something that really interferes with the way we lead our lives, we need to be prepared for that. And if that happens differently, more severely, more often, um, or more broadly distributed, one has to think about that aspect of it. So, think data, but think models as well.
Yeah, I
Can
love
I
all of the points that.
can I add something that Casey touched base is that we have been talking about a lot of like what is available, the data, the understanding of our system, etc. But I want to highlight the fact that we cannot do this alone. So NASA cannot do this alone. And as Casey says, there's multiple ways that you can contribute. We need scientists, but we need engineers, we need program managers, we need lawyers, we need people that can communicate the science. So bottom line here is that there's multiple ways that you can contribute. And if you're a student listening to this conversation, there's a place for you if you really want to make an impact in the Earth system science.
Yeah,
Yeah, I
I
love.
can. Go ahead.
Oh no, it's okay. You go, Jack.
Oh, I'm going to say that I historically felt that it was a great privilege to be able to do something where I felt that the science was fascinating, and the that technology, both on the sensor side, on the computing side, on the platform side, has been growing so rapidly that we're able to do things that literally have never been done in the history of humanity before, and to do that globally, and in many cases, one of the things that the space vantage point does is it lets us look at the whole world with more or less equivalent quality data, regardless of what's on the surface, or the development status of the area of the surface that you're looking at, but whether it's open ocean, boreal forest, tropical forest, ice sheets, deserts, mountains. The satellites see it all. So we have this sort of ubiquity of data that we never before have had in human history. And then the third part of it is working in a discipline that really has the opportunity to make a difference in the lives of people now and in the future. And I know I think about my grandkids, say, and say, what kind of world are they going to be living in? If we as a global society are going to make good decisions to help make sure that their world is as good as it can be, the data that and I don't just mean NASA, I mean the global community, all the organizations, whether it's governments or commercial, and all the academically trained scientists who are working, they get us the information we need. That's how the world is going to work towards having a better future. And there's not a lot of areas of science that really, the science is great, the technology is enabling things that otherwise might have been unimaginable, and they're doing something that really has the opportunity to improve lives of all the world's citizens now and into the future. That's a great privilege.
I love that. And Dr. K, I use the same word as well. I think of the privilege of the vantage of space that we get, and just to think about, we've talked quite a bit about climate and resilience and disaster response today, but there's so much that remote sensing empowers us to do as a community and eventually then as a global population. I was blown away when I first started working in this field and was working on anti-illegal fishing programs. And I didn't understand the connection that had obviously to feeding and food, to marine biodiversity, but also to slavery. That is one of the largest pathways to modern day slavery is anti-illegal fishing, which you uniquely need satellites to engage in if you want to have a swift response. Things like anti-poaching in African wildlife parks, or monitoring pandemic spread from space during the Ebola crisis, and sort of the list goes on and on. So even if climate isn't, in and of itself something that someone wants to study or have that impact on, there are so many humanitarian and biodiversity applications of this and justice elements of what we get with this privilege, that just to continue to invite people to think about the role that they can potentially play using this incredible data that's now available to us.
Yeah, I love everything that you guys are saying. I'm sitting here just so inspired, and I'm thinking about all of the ways that I can, leave this call and start working on some of these things that you guys are saying. This is so cool. Yeah, I believe this is the last question that we had. Is there anything else that anybody wants to add? Again, yeah, I just feel so inspired by what you guys are saying. It sounds like a lot of what you guys are highlighting, which is just so neat, is that with remote sensing and studying earth science, whether it's ocean, atmosphere, anything, that it really does come back to the community and being able to be, use that as your starting place to be able to make this accessible to people. But yeah, does anybody have anything else to add?
I just want to say that I have a lot of hope in you guys, in your the way that you're thinking, the way that you're seeing our planet, the way that you are like putting effort to join these programs and make a difference. So you are seen. We need you. We need more of you. Keep going. Always strive for excellence. Excellence not in a mean of perfection, but excellence in a mean of doing the best that you can with what you have. So keep going. At the Earth Science Division, we are always here to serve you. And if you have any questions, I'm open to answer any questions.
Yeah. Thank you, everybody. Yeah, this is really, really amazing, all the things that you guys have said. Let's see. So I guess with that, I think we can end our recording, and I think that will conclude our webinar for today. Thank you guys again.
Thank you.
Thank you.
Thank you.